Good day. Welcome to our first nostalgic math chat for IEB November 2023's paper 1. Let's ramble. So we are looking at question 4a in this video, which isn't I think it is like a level 1, or not level, maybe not level 1, level 1 true question. It's definitely not something you haven't encountered in your textbooks or something like it. But I just thought little tips and tricks that might be useful to highlight and just ease us into the paper, I guess. So let's do it. We have here, find the first derivative of f and g. G is on the next page. We'll look at that next. For each of the following. So the first function we're given is f of x, which is the fifth root of x squared minus 3 over x to the 3. Okay, so the key thing when you are asked to find the first derivative of an expression is you want to get your expression to look like this kind of thing, right? Right? So you want to have some constant. It could be a fraction, it could be a negative integer, whatever. X, okay, so we don't want x in a denominator, we don't want x in a square root, we just want x to the power of some number as well. Again, could be a fraction, could be a negative integer, could be potato, patata, patoot, right? Okay, so we want our expression to look something like this. So that's always the first task, is to try and get our expression to look as, sometimes I feel like I erase things too quickly. But yes, almost as simple looking as possible. Okay, so we're going to look at each term, okay, and figure out how we can write it like this. Okay, and the reason why we want it like this, of course, is because we know that our shortcut derivative rule anyway tells us that the first derivative of that guy will just be b times a times x to the power of b minus 1. So once our expressions look like that, it's easy enough to just apply the shortcut rule and find the derivative. Okay, so for our first term, we're going to use the fact that we know that if you have something like this, it is just the same as a to the power of m over n. So over here, it will be x to the power of 2 over 5. Okay, so it's a little bit of exponents knowledge coming in handy there. Okay, and then for the second term, we're going to use the fact that 1 over x to the a is just the same as x to the power of negative a. So the fact that we have a 3 up there, okay, just means we can look as we remember if you have something like 3 over m, that's just the same as 3 over 1 times 1 over m. It's just the same as 3 times 1 over m, right? And using this little rule, that would be the same as 3 times m to the power of negative 1, right? So we use that same logic here to say, okay, this is 3 times x to the negative 3. Okay. Right. Okay, so now we have our expression the way we want it to look, right? We have, if you want, 1x to the power of 2/5 minus 3x to the negative 3. So it looks like what we were aspiring towards. So that means we can now apply our shortcut rules. So 2/5 times 1 is just 2/5. And then we have x to the power of 2/5 minus 1. And then here we'll have negative 3 times negative 3, right? That exponent. and then x to the power of negative 3 minus 1. Okay, so then we've got 2/5 x to the negative 3/5 minus, so that's plus 9x to the negative 4. Now, I don't know if there's a particular rule of all powers must be expressed as positives. I think sometimes that's explicitly said. I think, yeah, it's just a habit of mine to always try and express my final answer with positive exponents. So I would go further to say, okay, this is 2/5 times 1 over x to the 3/5 plus 9 times 1 over x to the 4. Okay, so that then becomes 2 and 5x to the 3/5 plus 9 over x to the 4. If you want to go an extra yard, you can then write that the 5th root of x cubed. Okay, that looks a bit confusing. It's like, who does this little 5 belong to? Okay, plus 9 over x to the 4. Okay, let's see what the memo thinks of our efforts. Question 4A1, we have, and they have the answer with negative exponents. So yeah, all that last bit of work, not completely necessary. Okay, good and well. So that's our first one. Let's look at the next one. So g of x looking a bit more interesting. Okay, so we have x squared minus 2x plus 1 over 4x minus 4. Okay, so in order for us to simplify this expression, okay, we again want to remember something like, oopsie, a times x to the b plus c times x to the d, and so on. That's the goal. Right now we have a fraction where, you know, if it was just the one term, then we could split the fraction up. It's x squared over 4x minus 2x over 4x plus 1 over 4x, and then simplify it from there. But because there's two terms in the bottom, we can't split our fraction, at least not usefully. And we also can't just like go crazy and start cancelling. You can only cancel if it's one term at the top and one term at the bottom. And that kind of gives us a hint of what to do. If we want to do cancelling, we need to turn these three terms into one term, these two terms into one term. And how do we do that? That sounds like a job for factorising. So the top is a trinomial, x minus 1 squared. And the bottom, I can take out a highest common factor of 4, and I'm left with 4 times x minus 1. So in fact, just to then make it abundantly clear to the person reading my work, what I can then do is I now have one term at the top, one term at the bottom. I can cancel. So x minus 1 over x minus 1 just leaves 1 over 1. So this will end up being x minus 1 over 4. Okay, and then now, because we just have one term at the bottom, we can split our fraction up. This is the same as x over 4 minus 1 over 4. And just to make things very clear to ourselves, this is the same as a quarter of x minus a quarter. So then, oh, what did I do in the first question? Oh my goodness. Did I just start differentiating in the middle of nowhere? Oh dear Lord. Okay, so what I should have said here is the first derivative, okay, not just continuing from f. Okay, this is where we start doing the derivative work. Okay, cool. Anyway, I repent and I am forgiven. So this will now be, will just become, so this is a quarter x to the power of 1, right? So if we say 1 times a quarter times x to the 1 minus 1, okay, that's just a quarter x to the 0, and this just becomes 1. Okay, so that will just be a quarter, and then this, when you differentiate a constant, you get 0. So our final answer then is just a quarter. And the memo agrees. Awesome.